for my video. I know it's 2:25. I had to charge my computer because I got down to 20%. During my last video, I always end the day with the last, which is the best. Don't tell everybody that. Side note, Mesa, did you know when your email comes up, it comes as grin? Now I feel like we've had this conversation. Mesa grin kind of made me grin. Haha, lame. I think we've had this conversation before, but I just wanted to bring it up again. Okay, so warm up. It is the use substitution method. Okay, you have this function right here that's inside of two different types of functions, if you want to think of it. It's inside of a reciprocal function. It's also inside of something being cubed. So u and du, which gives me 2x plus 2. So here's the question. I have 2x plus 2, but how in the world is I going to get rid of x plus 1? Well, if you factor out a 2, it does actually get rid of that x plus 1. So x plus 1 over u times, and replacing the dx, I didn't write it, sorry. And that would give you 1 over 2x plus 1 du. So 1 over 2x plus 1 du. The x plus 1s will cancel. I can kick out the 2, or the 1/2. And what I did forget is that there should be a cubed right here. I knew I was going to do it. So I'm going to make it u to the negative third, and then go ahead and integrate. When you do that, and you integrate it, you're going to add 1, which gets you negative 2. The reciprocal to that is negative 1/2, so we get negative 1/4, and then u to the negative second plus c, which really turns out to be negative 1/4 on the bottom, sorry, x squared plus 2x plus 3 squared plus c. All right, so that is the warm-up. So this is going to be my introduction. I'm going to go through and do integration by parts in the rule, and then I'm going to go through all of this. I'm going to do one and probably another example, and then I'm going to end the video, and then I'll jump through a bunch of, or we'll do a bunch of examples from there. So I'm not going to jump. That would be weird. All right, and you wouldn't even know if I did. So if we integrated that x, we get 1/2 x squared plus c. Agreed? If we integrated this x squared, we add the 1, that gives us 3. The reciprocal to that is 1/3. So we get 1/3 x cubed plus c, right? True or false? If I take x times x, which is equivalent to x squared, and I separate it this way, will I get the same answer? Well, let's see. We said x squared is 1/3 x cubed plus c, but we don't need to write it. And then if we have just the derivative of x, integral of x, you get 1/2 x squared times 1/2 x squared. Well, right away you can see the 1/2 and 1/2 will not give you a 4, or 1/3 will give you a 4th, and x squared and x squared will give you x to the 4th power, and not that. So this is false. And the whole leading up to that is basically we're going to learn integration by parts because we can't use this method when there are two functions multiplied together. There's different ways to write it. I'm going to write it like with the f and g on the outside. The way in the box I'm going to write it is what you're going to see. So basically it's saying is you have function f and g, but we're going to say g prime of dx, and it would equal f times g minus the integral, not confusing yet, right, of f prime g dx. So not confusing, not at all. Let's just add some more letters. So this one uses u and v. It's real fun. And this is the whole integration by parts, and these are the letters you'll be using. It's weird, just go with it. It's just a way to separate it. So if we have u and dv, the dv is representing the derivative of v, and hence the dx kind of technically, equals u times v minus the integral of v times du. All right? You'll get used to this. It's really strange. Just keep going with it. I'm going to see if I can, is there any way I can copy and paste this? Because I'm lazy. Awesome. Okay, so I'm going to put this over here. Of course, then it does that. Actually, I'm going to put this down here. I'm writing so much with all these videos, I'm actually like, my hand's sore. It's really weird. All right, so the first thing we need to talk about is this Lie-8 method. And a Lie-8 method is just basically an acronym to help break down what you're going to use to figure out the U. So, go figure, didn't put the pen back. Whoops. So how to choose you. How to choose you. I would choose all of you. Okay, lame joke again. All right, so L is for logarithm. I can hear like you all starting to sing the oh my god, SpongeBob song, and I would hate it. I could just see it. I don't even know it, but I can see it. L is for log. I is for inverse trig. A is for algebraic expression. T is for trig. And last but not least, you are right, Katie. It is exponential. See what I did there? It's funny. I know. All right. So these are all the steps, and you can totally read through them, but I'm just going to jump right into it. So the best thing I can tell you is just know light and try to remember what it stands for and helping you pick the U. Okay. So it does say down here you're going to do like this table. I'm not really going to make it a table. I guess I can. Why not? I'll make it a table. I didn't do it in my notes, but I'll do it. But I'm just going to make it like just that. That we don't need to make it too complicated. Okay. So the first thing you have to do is pick U. And it's either a logarithmic, inverse, algebraic, trig, or exponential. Well, what comes first? Well, this is considered an algebraic, and I would write these in your notes. And this is considered a trig. So which one comes first? Algebraic. So that means that's the U. What you're going to do then is go down and do the derivative of du, the derivative x, which is 1, and you integrated that with respect to x. So it's kind of, this part is just like U substitution. It's kind of just like a bigger version of it, okay? Then you're going to write dv, and just follow the setup, but just know like here you're differentiating, and here down you're integrating. You're going backwards. So the other function is going to be cosine. So whatever you don't use, you write, and you take the dx with it, okay? It's not super important if you don't write it, just let you know, but just do it. Okay, I'll probably forget it. So when you go back to v, it means you're anti-deriving. You're going backwards, so that's why you're integrating from here to here. So the integral of cosine is sine of x, and you don't need to write the dx or anything. And then we write this rule. So I'm going to try to explain the direction you do. You do u times v, so you do that. So that's what we're going to write first. Okay, I like to say it's like this little weird x thing that you have to write. So u is x, v is sine of x. So that's the first part of the rule right here. Okay. You can see it. It's right here. I feel like I'm supporting Ashland University with the purple and yellow. So I'm not. I'm drinking out of my University of Findlay mug, right, Leah? And I literally just spilled coffee on myself. See, that's why you don't talk and drink coffee at the same time. Okay. Minus, and then you do the integral. This is where it's weird, and I always do that. One video, every video. You obviously don't know this because you haven't seen me record all my videos. But every video I click that little clicker on the side. The integral of v, so sine of x, times, that's where I like to say it's this weird little x thing that goes on. Let's do blue. And then you do v here. So you go down here, use v twice, go over. Taking advantage of v. Okay. And then you're going to write 1 dx. Now you don't really need to write the 1, so I'm just going to write the dx. The 1's pointless. And we go through, and we're good. All you have to do now is integrate. Okay. And the integral sine is negative sine of x, and it'll be plus c. So this turns out to be x sine of x plus sine of x plus c. Okay. So that's our answer right here. All right, so the answer to this right here, the integral of x cosine of x dx equals x sine of x plus c. Okay, that's the integral. All right, one more example, and we're going to cut off the video and then move on to more problems. Okay, so I won't lie to you. Sometimes you have to do this twice, and I'm just going to give you a heads up. You're going to do that now. All right, so the things you have to remember. Liate, the liate method, and then the integral of, if you remember, it's right down here. The integral of u times dv, we're going to write that down again. So the integral of u times dv equals uv minus v du. Okay, So we have to figure out what our u is. That is always the first step. Figure out u first. So many things I want to say, but I'm going to keep my mouth shut and not be lame. All right. So this function right here is algebraic, and this is exponential. And I want you to write this on in your notes, just so it's something to look back at to compare. Since it's algebraic, it comes before the e is exponential, so we're going to use x squared. And then you're going to derive it, which is 2x dx. And we're writing the dx because we derived and with respect to x, okay? And then the other function you don't use is going to be the dv every single time. So we didn't use the e dx, and we're going to use the dx. Again, it's really not that big a deal if you don't write it, but it's okay. And then we integrate from u to du, derive dv to v, you integrate, and that just happens to be e to the x. Okay, and then we make our weird little x pattern. So you go here and then here. So we're going to write this equals x squared times e to the x minus e to the x times 2x dx. So if there's one thing you know how to do right here, right now, with this integral, is that there's a 2 sitting in there. So you can kick that 2 out. The issue we're having after that step is there's an x still there. I'm going to write the x first because why not? Okay, this x is right here, so it's causing us an issue. We can't integrate it because it's two functions. There we go. There's 2 functions multiplied together. So once again, we have to do the integration by parts method. So we have to do it again. So I'm going to make a little dotted line to separate the work. And voila, on to the next part. Okay, so we have to do the whole u du thing again. And that line sucks. Let's try it again. Okay, and dv and v, and we're focusing on this part right here. So let's highlight this. So we're trying to integrate this, okay? The rest of it stays. So just keep that in mind. The rest of it stays. You could have kept the 2 inside of here and just kept going. I kicked it out here, but on my notes when I did it myself, I didn't. So like I said, it doesn't really matter, okay? Once again, this is exponential. This is algebraic. So our u is x. Oh, look, I got a message. Okay. Derive dx and you get 1 dx. Okay, so here's my hint to you. If this du has a variable or a function that still could be integrated, then I can't think of what I'm trying to do. I can't multitask. Right here or right here. If there's still an x, a variable, or a function, you're probably going to have to do this more than once. So like, let me go backtrack real quick. So, I'm getting a phone call. Okay, if you notice right here, there was no variable left. So we only did it once. But in this situation, we had a variable left, so we have to do it twice. Okay, so it just makes it more fun, more math, that's fine. Okay, we use the x, so we're left with the ex dx. And the integral, again, of that is just e to the x. So all of this is going to drop down. So we get x squared, e to the x, minus 2. And everything after this, because this is what we're integrating, this pinkish purple, this fuchsia, is going to go in parentheses. So we have to start the process all over again with our weird little x. And I'm going to make that, oops, highlighter. Wow. Yellow this time. So we go here. And then we go here. Okay. So we do x times e to the x minus the integral of e to the x. Don't need to write the 1, so I won't, dx. Okay, so we're good. We can do this. Hey, Katie, do you remember that really inappropriate thing I said? Right there. I have it on video, so hopefully I don't get in trouble. All right, so we're going to have to distribute that -2 through as we go. So we're going to multitask this. So -2x e to the x, 2 and, or -2 and the negative right here is going to make it positive 2, and the derivative of this is e to the x, and we write plus c, and that is our answer. That's it. That's done. Not too bad. Okay, so I'm going to highlight this just to feel like we did it. Okay, so I'm going to stop the video here. I'm going to do number 3 and 4 on one video and 5 and 6 on another video just to help break it up. All right, see you on the next video.